Hello, am I audible?
Yeah.
Yes, sir, we can hear you.
Yeah, sorry, there's some, I'm also connected from my tab for the presentation, but unfortunately, I'm not able to turn off the sound on that. And I think each time somebody joins, there is some ping that's happening. So maybe let's just wait for another couple of minutes for it to stabilize and get started. Yeah. Okay, so good evening, everyone. And I think we'll get started with today's session. Week 5 of the course on advanced application development, essentially the part 2 of the 2-part series course. What I'm planning to do over here is to look a little bit at how we can use APIs, right, application programming interfaces, within the context of a front-end framework like Vue. Okay, so what I'm going to be talking about primarily over here is a little bit about how you can sort of build an application using this concept of APIs. We already know a little bit about why APIs are useful. And in addition to that, I will talk a little bit about the background over here, which is some part of the thing which is to do with the asynchronous operations which are required in order to essentially interact with APIs, right? And finally, give a little bit of a code demonstration of how we can build a simple kind of application around this, right? Now, the goal over here is that all of you hopefully would then go forward and think about this in the context of the application that you did for the project last time around, which was the flashcards, and eventually sort of see how we can compartmentalize that, right? How do we build an API, and then how do we use it in order to implement a front end? And the sort of final project that we intend for this course is some kind of a variant on that, right? I mean, essentially, it's going to be sort of building on top of that. And these are all topics that we will be looking at over there. Okay. So I'm going to be turning off my video because I need to write on the tab. So, it'll be a little odd if I'm sort of looking somewhere and writing somewhere else. As usual, if there are any questions, then please feel free to ask. Okay. I'm not sure how well I'll be able to respond to messages in the chat, but if I do see it, I'll respond. Otherwise, please feel free to stop and ask. Okay, so now let's get on to the topic of APIs, right? Why do we even have this notion of an application programming interface, right? And it all comes down to something that we have been talking about from the early part of the modern application development part 1. And it's this notion that we call separation of concerns, right? We want to have different people in charge, or different programs or different processes or different systems in charge of the different parts of an application, right? And in this context, what we have done is that we have essentially taken a vertical slice, right? We sort of look at it as something which is a front and a back, right? And by front end, we mean the part which is closer to the user, right? The user interface. So the front end process, the front end code, in other words, basically manages user interface and all kinds of user interaction, right? The experience that the user gets when they use the application is managed based on the front end. And the back end then manages data models, okay? And what we ultimately want is to have some kind of a clean interaction mechanism that separates these two from each other, okay? So what are all the things that we could sort of state as being requirements of such a system? right? And what I mean by requirements are, let's think about it in terms, as a designer, right? Effectively, what we want is that the system level design should have a separate backend and front end. Now, why did we choose this backend versus front end kind of a division? Is it the only one? Is it the best one? It's not entirely obvious, right? But on the other hand, this is partly something that has evolved from experience, right? So the fact that a number of people have, even something like MVC, right? The model view controller ultimately has evolved from user experience or developer experience rather, right? People who had been building graphical user interfaces sort of thought about the entire process and said, okay, look, if we can separate out what the data model looks like from what the user interface looks like, it will become relatively easier to retarget. In other words, I can keep the same data model and move to a better user interface at some point if I want to. Okay. And effectively, some of the tenets that we have over here would be things like, the backend should never know what the user interface looks like. Okay, the data model that you are storing should not care whether you are displaying on a large screen or a small phone, what kind of colors are available to you. None of that should matter to the data model, right? Which means that there should be no direct calls to things like HTML template rendering and so on. The backend doesn't even care whether finally you are going to use it for a web app, which means that it's going to be rendered in terms of HTML, or it's going to be rendered actually as a desktop application, right? And that's the most interesting thing about this. In principle, with a backend that only takes care of managing the interface with the data, you could actually build up some kind of a desktop interface, right? And possibly even have additional functionality, right? But of course, normal desktop interfaces have some other properties in the sense that when I'm building a desktop app, I know, for example, that both the server and the client are running on the same machine and I can couple them tightly together, right? I don't need to have that sort of stateless protocol for the communication between them. In other words, the server can actually know at every point in time what the client looks like, right? But having the separation of concerns does help from a pure, abstraction point of view. Now, going further with that, what we would like is that the server should output its data in neutral formats. And what I mean by a neutral format is something which is, relatively easy to transfer over the network protocols used by the web, right? And at the same time is also relatively easy to parse. By parse, I mean, whoever is reading it should be able to make sense of whatever data has been transferred. And as we know, JSON is sort of the preferred format nowadays, right? A few years back, it used to be XML. Okay, so it's not that JSON is the only way of transferring structured data, right? In fact, what you'll find is that, even today, there are other variants of JSON because JSON has some defects. It has some problems when you're trying to transfer certain types of data. Okay, but it's a very simple format. It's easy to parse, and therefore it is almost ubiquitous, right? Meaning that you will find it in the majority of applications that are written today, right? The reason why I'm making a big deal about this is that you need to keep in mind that it's not essential. JSON is just one of the possible formats in which you can transfer data. And if you choose to have your API, output data in some other format, that's okay, as long as you inform the person who's using the API what format you're going to use. So all this is from the point of view of the system designer who's sort of making the backend, right? Now, as far as the front end is concerned, what it needs is there should be some way by which it can interact with the backend. And for that, there is this whole notion of a fetch mechanism, something that can retrieve data from a backend and basically, send information to the backend, right? It's not just a read-only interface to the backend. It might also be something where you're trying to create new data. And as we already saw in the context of REST in the previous semester, right? URL-based APIs are a good way of constructing something like this. Okay, and we are going to be spending a little bit more time on this moving forward. Okay, and finally, right, assuming that you are able to fetch the data, comes the rendering mechanism, right, which is going to be the front end. Now here also, there are different ways of doing it. Last time around, right, in the previous semester, what we did was effectively the front end, which is, retrieving the data from the backend API, is also running on the server. right? It was a Flask application that was also running on the server and was calling the render template functions in order to convert Jinja templates into HTML code. Okay. And what it does is it basically does all of that and pushes it to the browser. So the browser in that case becomes a very sort of trivial front end. It's not doing anything fancy. The only thing it can do is basically display whatever has been sent to it and also respond either when the user clicks on a link or when they click on a button or some kind of form submission mechanism. Okay, those are the only ways in which you can sort of send information or requests back to the server. Okay, in such a situation, the entire rendering is happening of the front end also is happening on the server. Okay. On the other hand, what we have been looking at so far this semester, right, is Vue, which is one of the many frameworks that are available that allows you to implement the front end completely in the browser. Okay. Now, what happens there? The front end is implemented in the browser, which means that you need some ability to program the browser in order to give it intelligence, in order to give it functionality, right? And that is achieved through JavaScript, which somehow by accident of convention became the standard language that is embedded in all browsers pretty much from the late 90s till today. Okay. Is it the only language that could have been put in there? Of course not. It just so happened that, it sort of grew organically, right? People put it in as a language just for extending browser functionality. And even though it had a lot of problems in terms of syntax and so on, over time it evolved and grew and improved to where we are today. Okay. So now that means that the rendering mechanism that we are going to be talking about is Vue, which builds on top of JavaScript. Okay, so far we sort of have a good understanding of what Vue is capable of. Let's see how we can make it interact with an API to get data. So like I said, the second part in this three-part thing, right? I mean, you have the backend server, you have the front-end display, and in between you have the fetch, which is the interaction between them. And this, brings in this notion of what's called an asynchronous operation. Okay. And why do we call it asynchronous? It's because when I make a request to fetch certain data and I'm going to use a URL approach, right? I basically make an HTTP request. There are factors that are outside the control of both the server as well as the client, right? Those factors include, is there some kind of a network disruption that temporarily happens between the client and the server, right? There is a process of DNS resolution, which means that the domain name of the server needs to be resolved properly by the client. There is ultimately the issue of latency to the backend, which means that the client is making a request to the server. That request has to go over a network and it then has to come back. You cannot always guarantee what the latency or the time, round trip time required for that response is going to be, right? It depends on the load on the server. It depends on the load on the network, various other kinds of things. Now, the problem is, supposing for every change that I want to make, I am going to make a request and then wait until the data comes back before I proceed, the user experience will be terrible, right? It will basically, because of the way that JavaScript works, right? In particular, because of the way JavaScript works. But if you think a little bit deeper about it, it's not just limited to JavaScript. The entire notion of having something where you need to make a request and wait for the data to come back means that if you are going to wait every time for it to respond, the user interface will be terrible. Okay, you click on something and it takes a while before the browser even responds to what you have done. Okay, it's like trying to ride a bicycle where if you turn the handlebars, right, the wheel turns only after a little while. Okay, you will basically fall off in no time at all. Okay, you just can't use an interface of that sort. So what is done instead is you do what's called an asynchronous operation, right? You essentially send out the request to fetch sort of in the background, okay? And then you wait for the results to come back. And as and when the results come, you update them, okay? And a lot of the power of JavaScript comes from answering this question. How do we do this? Okay, so let's take a closer look at that, right? So what we are going to do is take a little bit of a look at a few different concepts in this area, right? The first is this notion of something called a callback. I had spoken a little bit about it in one of the earlier sessions as well. But ultimately, the simplest way to think about a callback is just this, right? Let's say I have a function that I want to call, which is going to take a long time to execute. Okay. And in JavaScript, normally what I would need to do is just, I would have a command something like this. I would have a statement, let result equal do something. Okay. So do something, I know the moment that I start running that function is actually going to take a long time. Okay. And how do I know that it'll take a long time? Because I know the mechanisms involved. It might even be something as simple as, maybe adding 10 to the power of 12 numbers or something of that sort, right? It's just a for loop, which is going to take a very long time. But in practice, the more problematic scenarios are when I want to, let's say, fetch something over the network. Okay. Similar things include, let's say that I'm trying to open a file and read, several megabytes of data. Okay. Or I'm trying to, basically initialize something on disk, or I'm trying to interface with the serial port, right? Each of these things is something that, we might think that reading data from a disk or, sending data over a serial port is fast. But for a computer, they are very, very slow. Okay. Disks take on the order of milliseconds in order to really respond. And 1 millisecond is on the order of, 10 to the power of 6 clock cycles for a computer, right? And similarly, when you're sending data over a serial port, every byte that you send is taking several milliseconds, which again means, 10 to the power of 6, 10 to the power of 7 clock cycles per character that's being sent out. What do you do in the meantime? Do you just wait over there? If you try waiting, then what will happen is that the entire JavaScript interpreter will block. Block meaning it literally cannot do anything else. Okay. Think about what's happening when you write a C or Java or Python program, right? When the instructions over there are executed one by one in sequence, you reach a certain point, and if there is one function over there which takes a long time, it's not as though the program then goes across and starts executing the next instruction. It has to wait there until that has completed, right? Another way that we say this is to say that JavaScript is a so-called single-threaded system, right? Single-threaded basically means that the entire JavaScript interpreter runs in one process, right? Which is, in particular, it runs inside what's called one thread inside the operating system. Okay. Now, the operating system in principle is capable of implementing multiple threads that can execute concurrently with each other. But the entire JavaScript interpreter is basically one single thread. Okay. And in a single threaded system, if you block at any point, it hangs. Hangs meaning it will wait over there until you get out of that blocking call. Okay. How do we get around this? Start this do something function and leave instructions over there saying, look, as and when you finish, call me again. Okay, so what is this call me? It sounds very easy for me to say something of this sort, but it means that there has to be some mechanism inside the browser, inside the interpreter, and so on, which allows this business of call me when you are done to be executed. Okay, and that is essentially what a callback is. Okay, another context in which this becomes important is, let's say that you are writing a handler for what happens when you click on a button. Okay. Now, what does this button on click handler look like? We have already written some of these, right, in Vue and in JavaScript. So you know that essentially it just becomes a JavaScript function. Okay. But so you write the JavaScript function, but then go and look at your code. Are you ever going to call that function? No. You will never imperatively call something which is meant to be an on-click handler. Okay. It means that it is supposed to be associated with a particular event, right? So just like in the previous case where I had a long running function, and rather than waiting for the function to end, I want the function to basically be able to call me back when something happens. In the same way, for all these button clicks, which I don't know when they are going to happen, I would like the browser to be able to call me back whenever such an event happens. Okay. So the same thing we do, we basically take an event callback and tell the DOM or the document object model in that we specify if there is a particular event, it could be a click, it could be a double click, it could be a text entered in a field, right? It could be a mouse over a particular part of the DOM, right? Anytime something like that happens, invoke a particular function, call a particular function. Okay. So both of these essentially are examples of callbacks, right? And they are used in order to handle this scenario where there are certain functions that take much longer than others to execute. So now, in order to understand how exactly this whole business with callbacks is working, right, we need to understand a little bit about JavaScript event loops. Okay, so effectively, this is once again something that I had covered a little bit in one of the earlier lectures, but it bears repeating at this point, now that we have a little bit of a better understanding of what these function calls and so on look like, right? Let's go in and take a look at a couple of different examples that we have here. Okay, so I just need to switch my screen sharing. And, let me... yeah. All right. So yeah, so the first thing to sort of look at, if you are interested in this as a reference material, right, is you remember the live HTML5 document, right? We have already talked about it. HTML5 is a living standard. As part of that HTML5 document itself, there is a notion of the event loop. Okay, and if you look at it, it essentially says to coordinate events, user interaction, scripts, rendering network, and so forth, user agents must use event loops. Okay, each agent has an associated event loop, which is unique to that agent. Okay, now think about that. Effectively, the interesting thing over here, right, is that when you read this, it sort of becomes clear that when you're talking about each user agent, effectively what it means is that each window or each tab that is present in this browser will be treated as a different user agent. Okay, so effectively, in other words, what it means is that one event loop is created, one JavaScript interpreter is, or one instance of that, or one thread of that is effectively running for each and every tab that is present in this. Okay, which is why, even if one particular window sort of does something bad, it doesn't bring your entire browser crashing down. You can switch to other tabs, and hopefully at some point you will be able to close this tab alone that is causing problems. Okay, it should not kill your entire browser. Okay, not all browsers are implemented this way. There might in fact be something where you have some, a setup where multiple windows or multiple tabs share the same JavaScript interpreter. Okay, but generally speaking, well, that's not fully specified in detail, but a lot of information about what the event loop is supposed to do, what kind of event loops are there, and so on, right, are specified in this document. In fact, it also specifically says event loops do not necessarily correspond to implementation threads, right? For example, multiple window event loops could be cooperatively scheduled into a single thread, in which case, right, you could have a scenario where, one of them blocking could even cause the entire browser to hang. Okay, like I said, this is more of a reference material, right? I mean, it's useful if you want to sort of understand a little bit more about the details of how it is to be implemented. But the second link that I have put over here has a somewhat interesting animation, right, that shows a little bit about how the event loop works in practice, right? And effectively what it says is this, right? If this message, if you have seen this, the following page has become unresponsive, you can wait for them to become responsive or kill it, right? It basically is very likely, the reason for this is that your JavaScript interpreter has blocked. Okay. So now let's go and take a look at this animation that this person has done over here, right? Effectively, what he's saying is there is a lot of information which comes out which is put together in terms of how JavaScript executes functions, right? This big gray box that you have over here is essentially the JavaScript interpreter. This memory heap that you have over here is just the place where all the variables inside the JavaScript interpreter are created. So anytime you do a let or a const or something of that sort, right, especially if they're arrays, all of them get created on the heap. Okay. In addition to that, you also have something called a call stack. And the call stack is something which keeps track of all the functions that you need to execute. Okay. So this big gray box by itself is ultimately what any normal interpreter, whether it's Python or JavaScript or whatever, looks like. The thing about JavaScript is, in addition to this, it also interacts, right, via this arrow with certain web APIs. Okay. In particular, the web APIs that we are interested in right now, one of them is the DOM API, the document object model, which basically responds to all kinds of events. Okay, anytime you click or you enter data in a form, the DOM is being activated. Then there is another API called Ajax. Okay, Ajax is basically using what's called the XML HTTP request. Nowadays, of course, there are variants of this, right? It's not just Ajax that is being used. And there is yet another API of that's important, which is called the Timeout API. Okay, which basically allows us to set timeouts and call back into this interpreter at some point. Okay, so what's the interesting thing? Normally, this JavaScript interpreter would just be taking its code, putting functions on the call stack, executing each of them, and everyone's happy. It's just running like a Python program. Okay, but every now and then, these APIs that you have on the right over here can put functions into this so-called callback queue. Okay, and anytime that this call stack over here becomes empty, immediately the system goes, looks at the event loop, right? Looks at the callback queue, pulls out something from there and starts running that inside the interpreter. Okay, so by suitably putting things into the callback queue and making sure that whatever is in the regular call stack finishes, you keep on getting other things which are being pulled in from this callback queue and executed inside the interpreter. Okay, let's take a look at that, right? So he has a sort of series of steps out here, right? Where he's saying, okay, the initial state, right? The browser console, everything is clear. The call stack is clear, meaning that no functions are being executed right now. The web APIs are clear. No buttons have been clicked. No HTTP requests have come back. Everything is empty. Okay. And this interpreter now basically looks at a piece of JavaScript code and comes across one function, console.log hi. What does it do with that function? It puts it onto the call stack. Okay. Executes it, which means basically that, it goes, updates the browser console. What does it do after executing it? It pulls it off the call stack. Once again, the call stack is empty. It looks at the callback queue, empty, proceed. Take the next function, which is set timeout. Okay. So the set timeout is an interesting thing. It basically comes as one of the web API things, right? What it does is it takes the second argument, which is the CB1 in this case, and says, what happens when I execute the set timeout function? Something has to happen, right, in this call stack and the browser console. Let's see what happens. All that it has done is it takes this CB1 and puts it into this web API box over here. Okay. And as soon as it has put this information into the web API box, the set timeout function is done. It has finished execution. It is taken off the call stack. Okay. At this point, the web API box has this timer with this CB1 sitting on it. Okay. Proceed further. Now I do one more, console.log by, right? It gets added to the call stack. It executes, puts something onto the browser console, removed from the call stack. Okay. And now let's look at where we are, right? So the call stack is empty. Nothing else is there in my code, but this web API box is sitting there with a timer. Okay. So strictly speaking, if I look at my JavaScript program, the program is done because all the functions that were there, right? Console.log, set timeout, and console.log by have been completed. but there is still something sitting in this web API. Eventually, after some time, right, which in this case is 5,000 milliseconds because of what the value was used, the web API expires, right? That timeout expires. It takes that CB1 from here, right, and pushes it into the callback queue. Now at this point, the event loop sees that, yes, there is something in the callback queue. What does it do? It takes CB1 and puts it onto the call stack. Okay. From the call stack, CB1 internally calls console.log. Okay, so this is why it's a stack, because if there is some function call inside a function call, they keep on building up on top, one on top of another inside this call stack. Okay, in this case, there's just one function call console.log. It prints out CB1 into the browser console over here. Console.log exits from the call stack. CB1 exits from the call stack. Okay, and at this point, actually speaking, the entire program is done, right? There's nothing in the web API, nothing in the call stack, but the way the JavaScript works, right? As long as the browser is open, the event loop is still continuing to check this callback queue, right? We know for a fact that there is no way something can come onto the callback queue at this point because there is no program and there are no APIs that are dumping data onto the callback queue. But as far as the program is concerned, I mean, event loop is concerned, it's constantly going to monitor it. Okay, so this understanding, right, helps us to get a better picture for what this asynchronous operation is. And it's sort of useful to know that when you try and understand what you should put into an asynchronous operation, how you should manage these callbacks, right? Is it a good idea? You know, you just, I mean, the rule of thumb is anything which is long running, you know, just put it as a callback. But at the same time, if I take something very long running, put it over here, and finally it's going to get onto the call stack and take a long time to run, that's also going to be a problem. Okay. So, you know, you need to understand exactly what these web APIs and what they're capable of doing. Okay. Now, similarly, there is, you know, some information on the Mozilla developer website itself, right? It's a great source of information as usual. It has a lot of information about the concurrency model in JavaScript. Okay. And it basically tells you about the stack, objects, heaps, and so on, right? The same information. So I'm not really going into detail here. Just want to emphasize this one piece of information again over here, right? Which is this notion of run to completion, right? Which basically says that anything which is present in your call stack, right? Once a program enters your call stack, it has to run to completion. Okay. Now, what that effectively means is, you know, in terms of this diagram that we saw earlier, right? Supposing I do this console.log CB1, until this console.log CB1 completes, the system will remain over here. This call stack won't budge. No other function can come and run over here, right? This JavaScript interpreter is completely untouched by anything else. Okay. Now you might assume that, you know, isn't that normally what happens in any programming language? The answer is not necessarily, right? Because as they have mentioned over here, in a C program, for example, when a function runs in a thread, the runtime system may stop it to run some other code in another thread. Okay. Whereas in JavaScript, at least, what happens is that once it starts running, as far as the JavaScript interpreter is concerned, nothing in that runtime can stop it to try and run something in another thread. Okay. So if there is something which is very long running, which is going to be, you know, active in one particular thread inside the event loop, then that's basically going to stay over there and block your program. Okay. Why is this important? Because it means that you need to be extra careful about how you handle this whole business of, you know, having things that are short running, that terminate quickly. Okay. Yeah. Yeah. So, you know, going further on from there, effectively what we have is, so with all this in mind, a callback can be defined as a higher order function. So what's a higher order function? It's a fancy name for a function that can call another function. Okay. Or rather that can take a function as a argument. Okay. So this do something over here is called a higher order function. And the reason it's called a higher order function is because it takes two other functions, success CB and failure CB, as arguments. And what it says is, internally it might do some computation. If the result works out to be true or successful in some way, it calls one particular function CB, success CB, else it calls the other function, failure CB, right? Which means that depending on whether it succeeded or failed, I can make the system do different things. Okay. The same thing holds in JavaScript, right? In general, in callbacks, this is what you want to do, right? You want to invoke some kind of a long running computation and you want to give it two options, success or failure. And depending on success or failure, it should call one of two different functions. Now, promises are just another syntax in some sense, right? That allows us to do the same thing. Okay. And in fact, if we look at this, right, once again, the Mozilla Developer Network, it's once again, you can think of it, it says a lot of stuff. It's a returned object to which you attach callbacks and so on and so forth. But at the end of the day, right, you can think of it also like this, right? You could have written a function in this way, right? Just like what I showed you, which is you call the function and you pass it these two success and failure callbacks. Instead of that, you could also write it in a slightly different manner using this .then, right? Which means that this create audio file async, rather than being a function call by itself, is something that is returning what we call a promise. Okay. And a promise, the word is used basically because it refers to something that's going to happen in future. It essentially promises to complete, right, in one way or the other, either as a success or as a failure. Okay. And effectively, it allows you, using this different way of writing it, right? It's not just a syntax change. It also allows you to do certain things. Whatever could have been done with callbacks can also be done with the present system. But one of the most important things is what's called chaining, right? You can effectively create something which says, you create one promise in this way, right? Using this do something. And then I can create another promise, right? Based on this. So in other words, the success callback or failure callback, whichever one it is gets called when this promise resolves, has to in turn return a promise. Okay. So which means that you can then basically say const promise to, you can do this, do something .then success callback, failure callback, right? And then I could then have a .then on that, which basically says, depending on the output from that, do something further. Okay. So long and short of it is that these promises, right, you can think of them essentially as just something which is referring to, an event that has to happen in the future. You want something to get successfully done and completed, right? And this is a clean syntax that allows you to write it in a neat way. That's the simplest way of thinking about it, right? Of course, that's probably also oversimplifying a little, but it's a good starting point, right? And from there, you can sort of say, okay, what am I going to be using promises for? Primarily for fetching data. There, I need to sort of think about what are all the possible success and failure modes. And based on that, I can then chain these different promises together and handle all the different kinds of behaviors. Right? Okay, so now that we have promises, right, what can we do with this? There is one further piece of information I wanted to talk about, right, which is not directly relevant to your understanding of promises, but could matter when you are thinking about, especially, things which are more computationally intensive, right? There is a difference between what's called concurrency and parallelism. Okay. Let me see if I can. Sorry, hey, let me just switch over back to the other thing. Yeah. So, there is this notion of concurrency and parallelism, right? Now, in a lot of contexts, it is easy to think that both of these refer to the same thing. Okay, that concurrency and parallelism basically mean the same, but they are not. Okay, they refer to something slightly different. Let's say that you are trying to do two different things, right? Let me just. There is a task T1, okay, which is going to take, let's say, some amount of time, right? And there is another task T2, right, which takes some other amount of time. Okay. Now, if I had only one processor, right, how would I normally run this? I would basically run the entire T1, right? And then I would run T2 after this, right? And the total time that it takes would be T1 plus T2, okay, to execute both the tasks. But when I look at it, it's very clear that at this point in time, T1 is over, right? And over here, when I look at it, T1 and T2 are over, right? Now, there is another way in which I could do exactly the same thing, which is that I could say, I will start T1, right? Do a little bit of T1, okay? Switch over to T2, do it for a little bit of time, switch back to T1, switch back to T2, right? Do T1, do T2, and so on. And eventually, after some time, T1 is completed over here and T2 is completed over here. Okay. From the user's point of view, right, it would look as though there is one chunk of time during which T1 and T2 are both running. And at the end, T1 and T2 are completed. Okay. Why would it look like this? It would look like this if these chunks that I'm breaking it into are small enough. Okay. So I break it into small chunks of, let's say a few thousand instructions inside the CPU, right? And then I switch over another few thousand instructions for T2, few thousand for T1, 1000 for T2, 1000 for T1, 1000 for T2, right? Now, the point is 1000 instructions inside a CPU is only 1 microsecond. Okay, so even if I do, let's say, 1,000,000 instructions inside the CPU, I can do this jumping back and forth 1,000 times in 1 second, right? Which means that as far as the user is concerned, you can't tell it looks to you as though T1 and T2 are completely running at the same time. Okay. But when you go and look inside the CPU, at any point in time, either T1 is running or T2 is running. There is no parallelism, right? Both cannot run at the same time. Okay. On the other hand, parallelism basically means that I would actually have two CPUs. T1 runs on CPU 1 and T2 runs on CPU 2. Okay. At this point, T1 and T2 are both completed, right? And the time required less than T1 plus T2 time. Okay, it can be significantly less. It could be like half of what T1 plus T2 would take, right? So the point that I'm trying to make over here is that concurrency is what is more important from the point of view of the user. As far as the user is concerned, if the CPU at least looks like it is doing multiple things at the same time, right? You sort of have this implicit thing that, everything is working the way that, things are sort of going along simultaneously. Okay. Parallelism is something slightly different. That can actually happen only if you physically have multiple CPUs present. Okay. So even if I don't actually physically have parallelism, I can still have concurrency. In other words, even with a single thread or a single CPU, I can make the user feel as though multiple things are happening at the same time. And that is precisely what happens with any computer today, right? After all, when you have, let's say, even a Windows laptop, right? You move the mouse sort of, the cursor moves around on the screen. You type something on the keyboard, something comes up on the screen. What is happening is that the CPU hundreds of times per second is going and checking where the mouse pointer should be and redrawing it. And hundreds of times per second is looking at whether there has been a new key pressed and then deciding what to enter where. And in the meantime is going around redrawing whatever needs to be there on the screen, right? Just one CPU is required for all that. You don't really need any parallel processors, right? The bottom line is that you can effectively give the illusion of multiple things happening simultaneously. Whereas for them to actually physically happen simultaneously, you need parallelism, which may not always be possible. Okay. Why is all this important? Because you remember that I told you there were these multiple APIs, the DOM, as well as the timeout and so on, which can basically add things to your callback queue, right? There is also this notion of something called a web worker, right? Which is how you can actually create your own new things that can execute other functionality in parallel. Okay. So this is a bit more of an advanced topic. I'm not going to be discussing it in this course for the most part. But for those who are interested and actually want to know how we can make use of this long-running things being run in a separate thread, because after all, JavaScript is a single-threaded platform. Web workers are what it takes. All right. So bottom line, there is something called a fetch operation, right, which allows you to fetch URLs. It must be asynchronous for the simple reason that there is no guarantee on network speeds and various other things that we discussed already. And JavaScript, since ECMAScript 6, right, around 2015 or so, provides this fetch API that we can use, right? It is implemented using the promise, that syntax, right? And it is built into pretty much every browser that you are going to encounter today. Having said that, if somebody has something which is particularly old, JavaScript has this notion of something called polyfills, okay, which are basically used in order to implement backwards compatibility. Okay. For the most part, these are things that at present, at least, you should not need to worry about. But if you are sort of, getting into larger application development and you want to be able to support older browsers or older phones or something of that sort, at some point you might find that you at least need to know what these are. The fact that polyfills can be used in order to provide backwards compatibility. Okay. I'm going to mention along with the fetch API, there is also something else, another API called Axios, right, which is a custom library which is with similar functionality to fetch. It can be used on most browsers, provides good backward compatibility, and it also works with Node.js, which means basically that it works on the server side as well. Okay. And this link that I've given over here, right, basically provides some interesting insights into why you might prefer one or the other, Axios or fetch. Okay. It turns out that for certain kinds of things, Axios is a little easier, right, to write code. The problem with Axios is simply that it's not part of the built-in API, right? So you need to basically include a new JavaScript library just to use Axios. Having said that, in a lot of ways, it is very convenient. So, whether you choose to use Axios later is up to you. But I would say that to start with, at least, just use the regular fetch API so that you know what is provided and what are the capabilities of the base browser. Okay. Now, effectively, we are coming to the part which is the demonstration, right? So for that, what I want to do is to talk about existing APIs, right, that we can use in order to build sort of, functionality around them. Okay. And in order to build a front end, right, to start with, at least, you might be interested in using and understanding some of the public and useful APIs that already exist. Okay. And once you start looking at that, you will find that it's actually possible to develop fairly interesting apps just by accessing publicly available APIs. Okay. So for this, let me just show you some examples out here. Yeah, what we have are so if you look at something like api.github.com, okay. Now this is interesting. You just go to the website api.github.com, right? And this is the information that it returns to you. You'll notice that it's not an HTML file at all, right? What it has given is actually JSON, right? And there's a lot of information there. It tells you, certain things like current user URL, authorization, right? Lots of interesting looking URLs that it is providing over here, right? But it's not very clear what exactly you can do with that. Now let's look at something like this, right? And when you just go and look at users, effectively, you will find that, it's basically dumping out a large number of users out here. Okay. And what we can see over here, right? It basically has all this information about, the login information about users and things like that. And if I look at this one, for example, which is my user ID, it says login information is this, the ID is this, node ID, I have no idea what this is. It has some other information out here, right? It actually sort of shows various URLs. I mean, this is the sort of, this is the present URL that I am at right now. This would be the HTML URL, which can be used in order to see the user page, right? And then you will actually see that, there are certain URLs that are provided over here, which have a slightly interesting format. They are, they have this, but they also have something which basically says there is some part of the URL which is within curly brackets like this, right? And if you look at it, what you'll realize is that this is actually a way by which it is specifying that if nchandra75 was following some other user, this URL would return some kind of status code.
Yes, sir. Yeah, we can move forward.
Okay, thanks. Yeah, so what I was saying was that this notation out here basically would, if I typed in some other user's name, then I would find it would return a status code which says something like a true or false equivalent, depending on whether I was following that user or not. Okay, and various other things of that sort. So I can also see starred, owner, repo, and things like that. Right? And if you look at this, right, this particular notation that we are using over here is ultimately what was being mentioned as the core idea of the REST API, right? Which is that one of the ideas of REST was that this whole hypermedia, right, could be used as the engine of application state, right? I mean, there is that notion out there. The core idea over there is that when you go to a server, the server itself will provide you with further links that you can follow in order to get more information about the system. Okay. And this is essentially the format that GitHub is using in order to provide that information to you. Okay. There are other kinds of things that can be done as well, right? I think there's a Media Wiki API, for example, right? So MediaWiki's API, for example, has this thing where, it has a lot of information which tells you, in fact, I had mentioned this last time around in the application development 1, right? And, by essentially clicking on any one of these things, you would find that, yeah, right. I mean, so for example, the REST API corresponding to this, you could use that. And if I go and click on page earth, right, it once again returns a whole lot of JavaScript, right? It basically gives me all this information out here. Okay. Not very nice to look at, but very informative from the point of view of if you want to consume the data from a computer and then build something on top of it. Okay, so these are some examples of APIs, but what I'm going to do now is to actually switch over and show you something which is building something on top of an existing API. Okay, so let me just get to that in a moment and then we'll go forward. Okay, so I'm just going to go ahead and share the desktop out here. All right. So this is a simple app that I'm showing. Hold on, I think I'm sharing some wrong thing out here. Sharing and sorry. Yeah, okay. So now you have the you can see the code that I have, right? Now, what is it that I'm trying to do, right? The thing that I'm interested in over here is something called Open Weather Map, right? And openweathermap.org provides something called a weather API. Okay, and in order to use this API, you basically need to sign up. Okay, and what happens when you sign up over here is that there are several different APIs like the current API weather data, and if you look at the API documentation, it basically tells you what the API can be called as, right? So for example, if I just give api.openweathermap.org and so on, right, I can actually get some useful information out of this. Now, first things first, let's take a look at how that works. Okay, I can just basically go to my screen over here, right? Let me just expand this in size a little bit. And I'll just write curl, okay, and give, let's say, Chennai, right? And the thing is, I need to also provide something called an app ID. Okay, now where does this app ID come from? That basically comes from after you sign in over here. Okay, so I already signed in. I have that information. Please don't use my app ID. I'll try and make sure. And I'm unfortunately, because it's in a live demo, my app ID is going to be public, which means that I'll have to go and disable this app ID after the lecture, right? But please feel free to sign up for your own app IDs on yourself, right? That essentially it's very easy to do, right? Now, what will happen when I just do curl and call this thing? Curl is going to issue an HTTP request to this server, right? And ask for this particular endpoint, data/2.5/weather, right? That's the API endpoint. And the query string that's being passed to that endpoint is Q equal to Chennai and app ID equals this information that I have out here. What do I do when I run it? It immediately gives me back JSON data. Okay, what is the data? You look at it and it basically says, coordinates. Longitude is 80 point this, latitude is 13 point this. Yes, that is Chennai's latitude, longitude. Now the weather, right? It has like multiple elements, but the one of the things that we have is, it has one array out here, but more importantly, this main object gives you the temperature, right? So 300.35, I mean, obviously this is in Kelvin, right? So minus 273, in other words, around 27 or so is the present temperature in Chennai. Feels like 303, right? Minimum temperature today was also 300 something, maximum temperature was 300.35, right? I mean, I don't know. I don't think this is very accurate because it's not as though minimum and maximum stayed within like, half a degree of each other today, but it doesn't matter, right? I mean, it's giving us some useful information. Okay. And it also has information about the name and etc. etc. Okay. How do we use this? So for that, let's first go and take a look at what we can build as an application, right? I'm going to first create this page, right? I have a standard head, and inside over here, I have some kind of a basic app, right? And in this app, I'm not going to go over these parts of it, right? I already have a input text box, which allows me to add new cities, right? And inside, I have a for loop which runs over each of the over some array or whatever it is, something over here, and creates a number of city components, right? And after all, this is a view application. So clearly, right, I have this component called city, right? And in this case, I'm saying that it has one property called C. Okay. Now I'm being a little bit sneaky over here. You will see why in a moment, right? When I actually show you how the thing gets implemented. What I'm doing is, rather than just passing the city name in here, I'm actually passing in an object into the component. Okay. And the reason why I'm doing that and why I'm saying that's being a little sneaky is, normally when you pass a property into a component in Vue, it is read only. You are not allowed to change it. Okay. But there are many things that I want to change inside the component. So for example, I want to be able to, update the temperature and update the value and so on, right? And by doing this, by passing in an object, right, it basically allows me to change those values, right? And effectively, by changing those values inside the component, I'm able to then force the top level component in order to update its state. Okay. Is this necessarily the best way of doing something in Vue? Probably not, right? So I'm not saying that this is how you should be writing code, but this is one way of solving a problem. You need to think about your specific application and see whether this would be a good way of doing it or not. Okay. Now, what does the app itself look like, right? Basically, I'm just, for dummy data, I'm populating it to start with, some few different city names. I also have this add city method and a remove city method at the top level. Okay. Add city, for example, would be called by this index.html, right? Whenever I make a change on the input text box, it would call the add city function. So now let's see what this looks like, right? If I actually go ahead and run this, right? Index1.html, right? So you see that it basically renders something like this. I had these 4 cities, Chennai, Mumbai, London, Paris over here. It basically uses the Bootstrap card component in order to format it. The current temperature, etc., everything for this is unknown. Okay. And I can add more cities, right? So I can, for example, type in New York, and I can type in New Delhi, right? Anything that I want, I can put in over here, right? It doesn't even have to be a real city. If this doesn't care, it's just going to add it to the list. Okay. Now, what happens right now when I click on update? It basically puts a message, something went wrong, don't know how to fetch data, right? And whichever one I update, that's the message that I'm going to get. Okay. So creating this kind of an interface right now should be within your grasp, right? You should be able to create something of this sort without too much difficulty. And of course, if you want, you can go around deleting things that, you don't want or are not working, right? And yes, all of this is a nice, simple Vue application. But clearly, it doesn't know how to fetch data. So that's where the problem is. How do we fix that? Let's go back to our code. What we ultimately need is that whenever I click on that update button, right, I'm going to call this update function out here. So if I go and look at the update function, right now, all that it does is it sets error to true, error message, don't know how to fetch data, and calls this force update. Okay. Now, by the way, this force update was required over here because at least, this was the way that I could figure out in order to actually cause the entire Vue system to trigger an update. There may be cleaner ways of doing this, but part of it is due to some issues with reactivity in Vue 2 at least, right? I don't know if Vue 3 solves all of these problems, but in Vue 2, it turns out that, because you are trying to set a value for an object, it doesn't automatically trigger the reactivity of the system. Okay. Now, the thing over here is it's clear that update is the part that we need to go and modify. Okay, so let's think about how we could do it. We know that we want to change something in update, right? Let's see whether this particular information, right, the fact that I could fetch something from this API could be used in order to get useful information out here. Okay, so let me start by essentially declaring, URL equals I'll just declare this in backticks, change this to I want to make it has to be this.c.name. Okay, and instead of just leaving it as API, I probably want to make it HTTP. Yes. All right. Okay, and now what I can do with this is, let's say, fetch URL. Okay, so what does fetch URL do? Fetch URL is basically supposed to go in there and perform a HTTP request to this particular URL, right? And what we are going to say is dot. I could do something like let response equals await fetch URL. Okay, and I should at that point, be able to set this to response dot JSON. Okay, let me see what happens if I run this. Okay, I don't know if I need to run one more fetch over here, but I'll just reload this page first. And if I go ahead and click on this, well, it returns something saying, okay, got an object promise, right? That's not really what I want. I want to actually get the, I think I need an await.
Await there, yeah.
Okay, so once I do this and I reload and click on update, yeah, it still shows something went wrong, but that's all right. But the point is I've got the data back. Okay, so now this looks promising. It means that I should now be able to go in there and get this, whatever is the data in my JSON present over here, and extract the information that I need from there. Okay, so I'm going to basically skip over the difficult parts and actually show you what the final code looks like. What I did was I actually wrote this as an update function, and instead of using await, I actually declared it as an async function. Right, you have to basically, I guess, I'm not sure if you need to do both, but the point is fetch is an async operation, right? Which means that you need to tell the system that the function that is calling fetch is in turn itself asynchronous, right? But what's it doing? It's basically going to, construct this URL in this way. I'm logging it to the console, but that's just for debugging. And then what I do is I call the fetch, and then I use the promise notation. Right? I say then, and I say, take the response. If the status response is greater than 400 and less than 600, it means there's a problem, right? Basically, 400, 404 or something of that sort is what you will get if there was no such city. Okay. It turns out that the Open Weather Map API doesn't return an error code, or rather doesn't give a network error, right? As such, it only gives you a response status, which is unknown. If it could not retrieve data for the city. If that happens, then I'll set the error message to true and say could not retrieve data. But assuming that that did not happen, I'll return the response.json, which in turn then that is, as we already saw, that's going to be a promise on its own, right? I then once again have to await that. So that's where the dot then of that promise. It comes up with an argument data, right, which I basically assign to one intermediate to my data property out here, right? This property C. I'm just basically going and updating that. So this is where I said I'm doing a little bit of cheating, right? I am basically taking this and directly modifying something which belongs to the parent. Okay. I call the update temp function out here, whose only job is basically, it checks whether this is actually present, parses the float, converts it to a, 1 decimal place, and, sets this value temp. Similarly, temp min and temp max. Okay. So, all right, now let's see what happens when we actually run this, right? So once again, it has the same behavior. Now, if I go and click on update Chennai, nice. It basically shows me the current temperature, min temperature, max temperature, and also when it was last updated, right? I click on it one more time, the last updated alone changes, but these values obviously don't. I can go click on Paris. I can go click on Mumbai, London, right? And I can add new information, right? I add New Delhi and update it. And yes, I get some information out there. And what happens when I update, put in some unknown city? Something went wrong. Okay, because it essentially received a 400 something error code over there. Okay, I want to delete something. Okay, all of that, the rest of the system basically remains exactly as it is. Right. So, the UI part of it, Vue has clearly sort of solved a lot of nice problems for us. It allowed us to create a very nice and fluid UI, and, the reactivity, all of those are very nicely taken care of, right? The crucial extra step all happened in this fetch. The actual data could be retrieved and, displayed in any manner that I wanted. Okay. Now let's say that instead of this, I wanted to have, my own sort of Wikipedia reading app. Okay. I could have done the same thing. I essentially have one small text box, a search box on top over there. And as and when I search for something, it does an API query and displays just, a small segment, whatever it is that I want on the screen, right? And in fact, can then sort of, update that as required. Okay. So the point I'm trying to make over here is you can do a lot of interesting applications even with existing APIs, right? But of course, if you want to write your own API, which you did last time around for the grade book, right? You could use exactly the same kind of approach and integrate that API with the user interface the way that we have done here. Okay. So, all right, that's pretty much what I wanted to cover for the day. So, I think it's a much shorter session than last time around, but hopefully, was clear enough. Now, I guess we're open for questions, so feel free. Are there any questions?
Hello.
Yes.
Good evening, sir.
Yeah.
Could you please run through the difference when we used await and when we didn't included the await? So the kind of responses it returned back to us. Could you please touch on that or elaborate that?
Yeah, let me see. So, first things first, what does fetch return? Fetch returns a promise. Okay. So the fetch API is something which, it's basically a function call, and always what happens is the return value of that function call is a promise, right? Which means that you have two ways of sort of getting the data out of that promise. Okay. One of them is this notation that I have over here, the dot then, right? What does a dot then in the case of a promise do? You can, in fact, this is a nice part of Visual Studio Code, right? It basically immediately even shows you some information about the method. And as you can see on the screen, it basically says on fulfilled and on rejected, there are like two separate things that can come up. Okay. The dot then is one way of writing the syntax, which basically says this first argument to the dot then will say, okay, this is what is the case when the promise actually succeeded. What should you do when the promise succeeded? Take whatever came as the response of that promise, right? And do something with it. Okay. Now, in our case, when the fetch URL returns successfully, we are not yet guaranteed.
Sorry, yeah.
Sorry, can you repeat that?
Tajid, but is it something like similar to when we were in the last time when we were using Swagger or the Postman to fetch the APIs and it returns some code along with the response, like 4 or 500? Is that something that fetch uses to decide which method to execute?
No. So fetch will, it will make a HTTP request to this URL. Okay, so I have constructed the URL over here. It is some HTTP : something, right? Which means that the fetch function will make a web request. How do you make a web request? You basically, connect to this, you find out the IP address of this server using DNS, right? Then you connect to port number 80 on that server, and then you send it a get something request, and you wait for the response from the server, right? So all this is what we discussed in MAD1, right? That server in turn will return two things. It will return an error status, and it will return a status code and a status, rather a response body. Okay. Now, as far as fetch is concerned, as soon as it gets a response from the server, the promise has succeeded. It doesn't care whether the promise was corresponding to, not found or authorization required or anything else of that sort. As soon as it got a response from the server, the promise has succeeded, right? Which is why in the success part of the promise, I still need to go and check the response status. Was the response status 404, meaning that, there was no city over here, right? Or it could even have been 401 or 403 or some other error message, which, I'm sort of clubbing everything together and just saying could not retrieve data. Because I know that anything in the 400 range means error in retrieving data, and anything in the 500 range means there was a server error, right? So that is defined by the HTTP standard. That has nothing to do with JavaScript. It has nothing to do with fetch. It has nothing to do with Swagger, right? It is defined by the HTTP standard itself. Okay. So what is happening over here is whenever the fetch completes, right, and I get back some response, as far as fetch is concerned, the promise succeeded. I go in here and check whether, okay, even though it succeeded, was the return code actually valid? If it was not, then I will still, go there and complain. I'll say that, I'll set the error message to true and say could not retrieve data, right? But if it was valid, that it was not one of these 400 to 600 range, I will return this. I will convert it to JSON and return. Then, that in turn is also a promise. I need to unwrap that promise further. I need to take the data and assign it into something else, update the temperature, right? Do whatever computations are required inside, and finally tell View to go and update everything. Finally, I have one dot catch. Sorry, one second. I have one dot catch, which is, anywhere it fails, whether it fails over here or whether it fails over here. How will it fail? It will fail only if, let's say, this fetch itself completely fails. Okay, that is, it could not connect, or the network itself was absent, or I could not do a DNS lookup, something of that sort. Then I will come to this catch over here, and I'll probably show this message saying network error. Right? You can try that. If you're running it on your own machine, you can probably just try disconnecting the Wi-Fi and the Ethernet and try running it and see what kind of error you see at that point. Okay. All right. Sorry, there are some raised hands. I'm not able to see them. I don't know whose hand is raised now. Nitish.
Yeah, so
yeah.
Yes, shall we start with?
That said, I think there is a complete video on fetch, how it can be used in different modes and how it is handled, all of it in a separate video.
Yeah, I think, the screencasts will cover this in more detail. So you should definitely be looking at those. The main thing I wanted to sort of show over here was just, how you can integrate it with an API as a starting point, but also, some of the things to think about, like, the what is actually happening, why it is asynchronous, why you need to, why should you care, basically. Okay, but yeah, I think look at the screencast. They also have like more detail on this. Yeah, sorry, the first person with the question, you can go ahead.
So one doubt here.
Yes.
So in the first, then we are checking with the response status, and the second, then we are updating the data.
Yes.
So why we use two thens? Why don't we do it in the first then itself, like updating the data?
No. So the first then, the first then what happens is that what it is actually returning is itself a promise, right? So this rest that we have over here doesn't actually have the data. That's just the way that the fetch API works, right? I think if you use Axios, it might be, I think it straight away returns the data or something like that. Because of the way fetch works, you need to have these nested thens. I mean, not nested, but chained thens.
So it's like the first promise returns only the status of the response.
Yeah.
The second, then will there be another network call for that?
No. The next one is just, it's returned a promise. That promise, you just need to go and evaluate it because it already succeeded. You just need to call the then on that, and you unwrap the data and do whatever you want with it.
No, sir. Like here we are seeing like response.json that you are returning, right?
Yeah.
Then it in the response itself there is a data in JSON, right?
Not really. I think response could be stream. So what you might want to read is the whole stream. So what it reads is the whole stream response.json and gives a promise actually that could actually read the whole stream and gives you as one whole content.
Yeah, actually, so that, yeah. So, I think to answer the question, is there another network request? No, there won't be, but it might still be waiting for data when it finally gets back. Right. So like they said, if there, let's say that you are actually, rather than just getting a small amount of data back in an API, let's say that you are getting quite a large amount, several megabytes or something like that, then how do you handle it? Right. The first promise would have come back as soon as it got a status code, but it is still waiting for the rest of the data to appear. So it is streaming, waiting for it, and finally will convert all of it to a JSON thing and send it back to you.
Okay,
so just like response.json, there are other options to response.text, response.blob, all of them return the same promise for different types of data. Sorry.
Okay, so thank you. I got the point. So if we use await, then
so await is basically, I mean, it's also, it would be the same thing. Ultimately, what is this fetch dot then doing? When the promise successfully resolves, it will call this part, right? So await is basically saying it is waiting for a successful evaluation of the fetch to start with. It returns something which once again you have to await it for its response, right? Because after all, whatever fetch returns is itself a promise. The only thing await does is it takes care of this first response. You have to await this response again in order to actually get the data. That's what happened in this part over here, right? I had to first await the fetch, and then I had to await the response.json to get the actual data back.
yes, I got it now.
Yeah, sorry. Next.
Basically, async and await makes it look like it is synchronous. If you see here, the flow looks like synchronous, even though it's asynchronous, where await is actually doing all the promise resolution and returning you to the actual value. In the other case, it's quite asynchronous, where you're writing then, or trying. You don't wait till, for example, after the fetch gets called, it obviously would have gone to the next step without even executing then, because then would get executed as and when the promise gets resolved. But here, it will not go to the next step until the await gets resolved. That's the difference.
Yeah.
Okay, so then the await means it waits till it gets resolved. The then is handled in the background.
Yeah.
Then is handled like a callback. Yeah.
Correct. It's more about the programming style, how you are, this is probably something that's a bit easier for people to, who are used to sort of regular imperative programming to get used to, right? That's the thing. Okay. Yeah. Sorry. Next question. One person had, two people had hands raised. I think
Jaidev.
Yeah. Jaidev.
Sir, could you go back to weather.js?
Weather.js. Yes.
So in line number 43, if you were to remove the async keyword from, it would still work, right?
In this case, I don't think so, actually.
It would work. It would work.
It would work?
Because
okay.
it would work.
Because
you need
and it would
async
work because there is no await.
Correct. Yes, thanks.
Okay.
Yeah, thanks for pointing.
But if I were to then write, well, let's say deal with futures generally just by doing a set of chained then statements, then I can avoid writing async await anywhere, right?
Yeah, you can avoid.
Okay.
Yeah, so like somebody has mentioned in the chat, I guess await can be thought of as a syntactic sugar, right? It makes it a bit easier to write code if you are not comfortable with this, chaining promises and the resolution of them. It makes it.
So as long as the last then doesn't return a response, and it actually, no, sorry, not returns a response. But the last then that I have in my chain, as long as that itself doesn't return a promise and it actually takes whatever action you want to take, then I can avoid doing async await.
I guess so. Yes.
Got it. Thanks.
There is also a need for await in certain cases where you, like for example, you are loading initial parameters from a web service and you don't want to continue further until you get all that data. Then await might be required because you want to wait till you get those initial configuration.
Like I don't want to do anything at all.
Correct. For example, when you want to load some of the basic, like say, configuration, which cities available, you want to show in a drop down as it loads. And you don't want to continue until you want to show all the cities available, for example.
Right.
And
so
then
if I
you
were
could
to
there, then you might want to put an await.
If I were to there simply write a set of thens, then they will anyway, outside of the fetch API, the other code will still execute.
Correct.
Okay. Which is exactly what I want to avoid in this case.
Correct.
Okay, thanks.
So I think there was one more hand raised.
Yes, sir. Sir, actually, my doubt here is like there is that fetch thing, right, sir? Fetch URL.
Yeah.
After that, we are using them, sir, and Tej sir pointed out that it's actually some kind of stream, like data is coming as the process is running, right, sir?
Yeah.
So is it means that while we get the data itself, we can access the data which we already got? Like dot status, we are checking that resp dot status greater than or equal to 500 or something, sir.
Yeah.
You pointed out that we are returning the rest.json because we don't want to return full a data which we got about 50% or 60% something. So in this case, is it possible like we are accessing data which we not fully received like that?
Yeah, okay, I think Tej will probably be able to give a more accurate answer, but I think, yes, you can access part of the data because resp.json is actually a promise, which means that by itself, it is not yet completed. It is not fully resolved. It is not, you will have to wait on it, using that then, and only when that then resolves to data, do you actually have the data. But the interesting thing, I think, is, using the partially received data, you can, for example, do something like showing progress bars, right? So there are sort of techniques that show you how much of the file has been downloaded and things like that. And that can be sort of done using but the partial data returned on the fetch. Right? I believe that is possible, but yeah.
Okay,
so,
sir.
yeah.
And one other doubt, sir, like we saw that JavaScript actually runs on a single thread, sir. So this fetch thing also is like that also. Like if in some promise, like in some dot then block, if something happens and it is not able to retrieve data and it is waiting, it will wait forever.
See, so that's the thing, right? Yeah. So it is run that fetch part of it and so on are actually running in a separate worker. Okay. So timers, the fetch, some of these APIs, like I said, the fetch API and so on, are not part of the main JavaScript interpreter thread. And that is the whole point. That is exactly why async works at all, right? If they were also, if this then was also executing in the same interpreter thread, then there is actually no use at all. Because like you said, there's every likelihood that the network might hang and you don't get data back. Okay. So then you don't want the interpreter to hang. The point is, by making it async, it is no longer in the same interpreter thread. So even though I say that JavaScript interpreter by itself is single threaded, that doesn't mean that everything in the browser is running in a single thread, right? It need not necessarily be multiple operating system threads. It might even just be something which is being done concurrently by using some kind of time slicing and so on. The point is, it can happen without making the browser hang.
Okay, sir. So it's some kind of callback, right, sir?
Ultimately, yes. Yeah. So that's what, it would finally go into that callback queue. And whenever the event loop is done with whatever else it was executing, it will go, wait for stuff over there, as and when the then resolves, as and when these promises resolve, they go and push stuff into the callback queue, which then gets pulled in for
getting the DOM.
Yeah, exactly. For further process.
Okay, sir. Okay, sir. Thank you, sir.
Sorry, there are a couple of messages in the chat. There was one early thing is Dart language future similar to JavaScript promise. Sorry, I don't know anything about that. I assume it is. It sounds very similar. I don't know, Tej, if you have used Dart, but I suspect it is probably very similar, right? I mean, there are many languages now that are coming up with this kind of asynchronous styles of programming. So even Rust and various others have these kind of things in them. Now, each one of them obviously calls it something different just to make life interesting, right? So very likely future in Dart is like promise in JavaScript, but I don't know. Yeah, one more, I had made a similar Vue project a couple of years back. Hey, great. I mean, it would be great if you can share. I would request that you put it on the discourse. So, that way I think a lot of people can get to see it. That would be great. I mean, it's definitely, I think, good to see other people's code and, understand more from that. Thanks for offering to share. There was one question, if it is an error and as response is an object which is not a promise, then second, then will execute or not? Sorry, I didn't understand that question. Where exactly are you saying if it is an error? This is
so I think if the first then throws an exception, then actually it will be caught by the catch and it will be handled.
Right.
Want to go to the second one.
Yeah. So I think if there is an error that is actually thrown at some point, it will go to the catch. See, this catch, by the way, one way of looking at it is that it is when a promise fails, right? So it is, I mean, at least, I think in the Mozilla documents, they in fact mentioned that one way of looking at catch is, you can think of it as the then, right? Then takes two parameters, right? One is the success callback and the second is the failure callback. Effectively, catch is like saying it is null for the success callback and giving you only the failure callback. It's basically saying, okay, the success part has failed. Now execute whatever is on the failure callback. So effectively, what will happen is any one of these things actually throws an error and they will get caught over here. Difference between XML, HTTP request and fetch. Yeah.
I mean, one is an older API.
Right.
I mean, with limited features. Fetch is a newer replacement for Ajax, which has like a lot more features and newer concepts to handle it. So you can see it as a newer version of Ajax's fetch. I mean, Ajax is still there if you want to use, but if you have a better API, why would you use a older API?
Right, exactly. There's one more question. Does using API have any effect on the security of data in the database? See, that's a totally different question, right? How you secure access. I mean, even an API, you should have some way by which you secure your access to it, right? If you implement an API and just make it so that it is publicly accessible on the internet, then whoever uses the API can mess around with your data. They can, at the very least, read data from the database. And if it's like a CRUD API, they can even go and modify your database. But on the other hand, let's say your API is in a server where you have taken other steps to make sure that it can be accessed only from certain front ends, like in Flask, for example, right? You could have a API which is running in a backend, but on a machine which is accessible only from certain front end servers. That's one way by which you can make sure that the access to the API goes only through that front end. But in other cases, like for example, even if you look at OpenWeatherMap or GitHub, how do they secure access to their APIs? They basically require either an API access key or some kind of a temporary token can be enforced. There are multiple ways in which you can enforce some kind of authentication before accessing an API. So you should not think of an API independent of security, right? An API at the end of the day is just some way by which you can sort of either get data from a database or modify the data in a database. So if you want to secure it, you have to do that properly, right? You can't say that I'll do the securing only based on whether it was a HTML front end or not. Okay, if response status is 400 and in the first if statement we are returning response, what would happen in second then as response is not a promise? It is still a promise. So I mean, I guess what you're saying is that I have just returned resp, not resp.json. I should probably have made this resp.json. The point is, even this resp at the end of the day is still a promise. Okay, it's, like Tej said, this resp.json is just something which allows you to, that the next stage can retrieve the data in JSON format. Whereas if you don't give it, I'm not sure, maybe it gives it as text format or something of that sort, right? Because yeah, it is still a promise that's going to be returned.
I mean, I would suggest you to go through the screencast. It deals with each one of these cases. There are about 5 cases that we go through in Fetch, including how to do put, post, how to upload a file and things like that. So you can explore many things. Abhishek, is that video is also scheduled for this week only, no?
Yeah, that has gone out.
Oh, okay. Thank you.
Okay, all right. So I think we can probably stop here. Okay, thanks everyone. And as usual, any questions, feel free to bring it up on discourse. And yeah, thank you. Bye-bye.
Thank you, sir. Good night.